bubbleSort compares two adjacent items and swap them if the first one is bigger than the second one. After each outer iteration or pass, the next bigger number moves up or bubbles up to its correct position. As you can see in the illustration, the outer loop is for passing over the array only once, and the inner loop goes through each item every time the outer loop iterates. So the outer loop is for passing and the inner loop is for comparison. The outer loop will run in respect to the number of items present in the array. In this demonstration, the outer loop will run 8 times. The inner loop runs all the way to the second last item because it's only comparing adjacent items, so no need to pick the last item for comparing. We are also subtracting the number of passes from the inner loop to avoid unnecessary comparison because the last item is already in the correct position in the previous pass. For swapping, we compare that if the current item j is bigger than the next item j plus 1, then we will swap. bubbleSort can be implemented as a function. It takes an unsorted array and returns a sorted array. There are two loops involved in the action of sorting. The outer loop, which goes to the end of the array only once, and the inner loop, which runs to the second last item minus the number of current passes. We are subtracting the current pass I from 1 minus the length of the array because it would be unnecessary to loop over part of the array which has already been sorted in the previous pass. Finally, we compare the current position of j to its adjacent item j plus 1. If it is bigger, then we swap. We are extracting the swapping mechanism in a separate function. First of all, we are declaring a temporary variable saving the current position of j in it. In line 15, we are moving j plus 1 to current position of j. In the final step, we have moved j, which was saved in the temporary variable, to the position of j plus 1. In the best case scenario, where our array is already sorted, the outer loop runs only once or just for one pass, which is O of 1. In the worst case scenario, the array is sorted in reverse order, so it is O of n or linear time. The inner loop only runs n minus 1 comparisons. For example, if we have 6 items, we need 5 comparisons, which is going to be in linear time for best and the worst case. On the whole, the bubbleSort runs O of n or linear time for the best case and O of n square or quadratic time for the worst case scenario. The term bubbleSort was first used by a Canadian computer scientist named Kenneth E. Iverson in 1962. Before, it was referred to as sorting by exchange or exchange sorting. It works by comparing the adjacent element in the array and exchanges those that are not in order. In each pass, the next largest value is placed in its proper place, or in other words, bubbles up to its correct location. Hence, number of comparison reduces 1 at each pass. For an n-element array, the code requires n minus 1 comparison for a pass. bubbleSort is an easy-to-implement stable sorting algorithm with a time complexity of O of n squared in an average and worst cases, and O of n in the best case.